Good evening. Welcome to New Horizons. If you have a mobile phone, if you'd like to put it on silent, please. Thank you. Right, massive welcome back to Andrew Johnson with Comets, Calamities and Planet X. Tonight, Andrew casts his gaze skywards and back in history to our visitors, the comets, asteroids and the mysterious Planet X. Andrew prefers to deal with evidence, as evidenced by his superb website over the W's, checktheevidence.com. Andrew will focus on recorded data from 2 space probes, recent cometary close calls, astronomical observations and major Earth strikes in modern times, one in England and one in Russia. Ladies and gentlemen, please welcome Andrew Johnson.
It's wonderful to be back here with you all again. It seems to get better every time I come. I got chocolate biscuits tonight, which has never happened before. I was treated like royalty. It's fantastic, you know. It's brilliant. So I'd like to thank everyone for setting up the equipment tonight and all the hard work that goes into that. Thanks to Rob and Chrissy for their wonderful hospitality when I come and visit. Thanks to everyone here for coming, particularly those that have come a long way. And I've got some DVDs there, as you see, which I sell for 50p. And I've got just 2 or 3 booklets left, because I haven't had time to print any more. And I've got a couple of the Judy Wood books, which people may know I've been associated with for a few years now. And we're running out of the current stock of those, so if you want to get a copy of the Judy Wood book without paying the excessive postage, which has just gone up again, then they're £25. But tonight I'm not talking about 9/11. Rob's already done the brief introduction. For those that don't know me, I work part-time for the Open University. I tutor on a course called Technologies in Practice, and I assess students with disabilities for access to equipment for higher education. So my degree was in computer science and physics, but I'm not an astronomer, although I have had a strong interest in astronomy since I was about 10 years old, and I think I know a little bit about astronomy, hopefully. So I'll try and go through this. I've got various video clips and stuff. We might have to fiddle with the sound slightly, so please bear with me if we have any little technical hitches. Okay, so we're going to look, as Rob said in brief, we're going to look at data about comets. We're going to look at data about the alleged Planet X, which a lot of people have been talking about, particularly in the run-up to 2012, which of course has now been and gone. We're going to look at predictions about the end of the world, which tied into 2012, and a bit of a history of these predictions, or some of them. And to help us understand comets and Planet X, we will look at the scale of the solar system. I've come to realise that not as many people as I thought actually understand and appreciate the scale of the solar system. And you have to understand this if you're going to understand or know about Planet X. You know, where is it? How far away is it? What size will it be? Well, I'm going to try and cover some of that data and explain to you, where I'm coming from on that. I also want to talk about comets. For example, Comet Wild 2, and Comet Halley, and Comet Tempel 1, because all of those comets have had probes sent to them, and we've got data back from those probes, right? So, since I was a kid, there was a big build-up to Comet Halley's reappearance in 1986, and I watched Comet Halley through a 12-inch telescope when I was down the road at Lancaster University. So there was a big build-up to that, and that was one of the first comets that had a probe sent to it, Giotto. So we're going to talk about some of that data and what's significant about it. Because, of course, as you know from the themes that I cover here, I'm not just going to be giving you what comes off the NASA website or what they say, is what it means. I'm going to tell you what I think it means based on other things that I've talked about here as well. We're going to look at the story of Comet Hale Bopp and the troubling way it was linked to an end-of-world prediction, right? Because there's quite a significant story there that maybe some of you will know, some of you perhaps not heard of. And it links directly into people that are currently doing the rounds on the internet as well. We're also going to look at the Tunguska Event of 1908, and I've got a clip from an old documentary series which many may remember fondly. I've got a 10-minute clip from that. And we're also going to mention the possible decimation of England in 562 by a cometary impact, which has been written about by Alan Wilson in his books. And then we'll look at the Chelyabinsk meteor as well a little bit. And I was actually, before I go into this, I was actually asked to put this presentation together by somebody I know in Derby, Omar Fowler, who runs a UFO group there, when everyone was talking about Comet Ison. So I've got a good bit about Comet Ison, which had an apparition in November last year. But I'll come to that later. So that's why I ended up putting this together. So what is the scale of the solar system? Well, let's have a look, shall we, a few of the things. So we'll start off with one of the inner planets, Mercury. It's 36 million miles from the Sun, right? So it's roughly a third of the distance away from the Sun that we are. We're about 93 million miles, the Earth. Look at the diameter of Mercury, it's 3,000 miles. We're at nearly 8,000 miles. The orbit of Mercury is 88 days. The Earth is obviously 365.25 days. The average temperature ranges between -183 and 427 centigrade, and we're 14 degrees. So I'm not going to read all of this out, obviously, but if we get out to Jupiter, the average distance is 483 million miles. That's 480, so half a billion miles, roughly. That's the rough. But of course, when you look at Jupiter, that you're looking out to it, well, I'll try and explain this on the next slide, the distance varies a lot, and you'll see why on the next slide. Saturn is roughly twice as far away as Jupiter, 800 million miles. Uranus, again, double that distance. Neptune, not quite double again. Pluto, which is no longer classed as a planet, is classed as a planetoid. It's too small to be classed as a planet. 4,584 million miles. So a billion, billion. It's 4 billion miles, basically, 4.5 billion miles. 4,584 million miles. And it has an orbit of 248 years. So that's just a quick run through the scale. Now, what we've also got to realise is we want to get a good feel for these distances so that we can talk sensibly about Planet X, which I'm going to come on to. And if you're going to talk in scientific terms, the typical unit that they use when they're talking about the solar system is what's called an astronomical unit. An astronomical unit is the distance, or the average distance, from the Earth to the Sun, and it's approximately 100 million miles. So that's what we're going to be thinking of in terms of when we're talking about distances in this presentation. So here we go, look. Jupiter is about 5 astronomical units away from the Sun, and it's between 4 and 6 astronomical units away from us, right? Saturn is about 9 astronomical units away from the Sun. That's between 8 and 10. So remember, if you look at this, you see, at various points in the Earth's orbit, we can be one side of the Sun, where the planet is the opposite side of the Sun. So you've got to add or subtract another astronomical unit to the average distance. You see what I mean? So you've got to think about things like that. That's why, for example, Mars at the moment is coming nearer to us, because it's on the same side of the Sun as us. And we're going to see it much significantly larger in telescopes than, to your naked eye, it'll still look the same. It's a red dot in the sky. But in telescopes, it'll look larger. The same is true of the outer planets. They can be on the same side of us, which is called superior conjunction, I think. And then if they're on the opposite side, they're in inferior conjunction. I might have got those the wrong way around, but that's what they put in the astronomy books. Okay? So think about that. When you look at these planets, they could be on the same side of the Sun as we are, and they're therefore closer to us, or they could be on the opposite side of the Sun, and then they look much further away. So again, a quick picture of the solar system that somebody drew up. I didn't draw this. You're going out. So basically, Pluto is about 100 times as far from the Sun as Mercury. 100 times. 10 to the 2. So it's a long way out. It's a long way out. Pluto wasn't discovered until 1930 by Clyde Tombaugh. All right? So it's smaller than the Moon. All right? So again, relative sizes, we've got the huge planets like Jupiter and Saturn, which Jupiter's the biggest. I think Saturn's about 2/3 the size. I could go back to that other table. I'm not too concerned with that. I'm more concerned with the distances and the relative sizes. We've also had some new dwarf planets discovered as well, which I'm going to talk a little bit more about later on. Sedna, and there's about 4 or 5 dwarf planets. Sedna is one, Makemake is another one, which you've probably never heard of. But it is now possible to detect planetoids and dwarf planets a long way away, way out beyond the orbit of Pluto with the more advanced equipment we've got now. So Quasar is approximately 800 miles in diameter. 800 miles is tiny. 800 miles is tiny. That's, you know, the size of Britain from top to bottom, just, well, roughly. Britain's probably about 550 miles top to bottom, so it's not much bigger than Britain. And it's further away from the Sun than Pluto, and they say it's primarily made of ices. This is from one of the NASA websites. And Makemake is the other one. Its diameter 950 miles, that's 1,500 kilometres. It is the third largest trans-Neptunian object after Eris and Pluto. It was originally designated 2005 FY9. So these have been observed with some type of either radio telescope or with an optical telescope. And it's, yeah. So we've got Eris, and this is, let's see, I'm trying to find the size on there. This object is about the same size as Pluto and currently about 3 times farther away from the Sun than Pluto. 3 times farther away. That makes it roughly 12 billion miles away. 12 billion miles. Right? And it's smaller than the Moon. They can see it, they can detect its movements. It's a long way out. Sedna, that was quite a bit of press about this. They said it was like a 10th planet. And I think if you look at that name in mythology, some people attached meaning to the mythology, and I forget what Sedna means, but it's a mythical figure in mythology, but I can't remember what it means. It was discovered in 2003. It is roughly 3 times further away than Pluto, again about 12 billion miles, outside the Kuiper Belt. You'll see about the Kuiper Belt in a video clip I've got shortly. And it is approximately 1,000 miles in diameter and takes nearly 10,500 years to go around the Sun just once. So they've confirmed from measurements over periods of months or days or weeks that it does indeed go around our Sun. It belongs to our solar system. But it's a long way out and has a very long orbit. So this picture here attempts to give you a picture of the scale of some of these orbits. So this is the inner solar system. I don't know if we can get the front lights down a bit here because some of this projector doesn't seem very bright. But basically, this is the inner solar system here. And then if you expand these lines out here, hopefully you can just see those lines. This is then the outer solar system. And then you go, that's better. And then you go to this picture here, and you've got the inner solar system in the middle of this ellipse. And then you go right out to what's called the Oort cloud. So some of these objects that have been detected are a long way out, 12 billion miles. 12 billion miles. And these are the relative sizes. So you see, there's the Moon. Pluto is smaller than the Moon. Quoar is smaller than Pluto. Sedna is about a little bit smaller than Pluto, and then you've got the Earth this size. So these are tiny objects that have been picked up 12 billion miles away, one with a 10,500 year orbit. Just bear those figures in mind if you can. I know I've reeled off very quickly a lot of figures, but the summary of that is they've detected some pretty small objects a long way off. Right? Now, of course, this information has come from NASA and so on, and the European Space Agency and other observatories. So, yeah, they can cover stuff up. They can cover stuff up. I've talked about that, right? But you'll see where I'm going with this soon. We now come to the Minor Planet Centre, which is a website you can go onto. Now, as I said, I prepared this presentation back in November, and the Minor Planet Centre has amateur observations submitted to it. You can get some pretty advanced amateur equipment now. You know, it might cost you a few £1,000s, but there is, as we'll come on, this is Comet Ison, for example, which we're going to come on to, was picked up by an amateur network. It wasn't picked up by professional astronomers. The Minor Planet Centre, or MPC, is the single worldwide location for receipt and distribution of positional measurements of minor planets, comets, and outer irregular natural satellites of the major planets. The table on the left is for November 2013. So if you look, near-Earth objects discovered in November last year. This month, 35. 35 objects which come within, I think, 1 million miles. They're classed as near-Earth objects. 35 were discovered last November. Last year, up to November, 888 were discovered. And all time, 10,000. So when minor planets discovered, this is minor planets discovered now, 352 were discovered in November, minor planets, last year. You can go and look at this. You can look at today's figures if you go onto this website, www.minorplanetcentre.net. You can go and look at this month's comets discovered. There were 3 comets discovered in November last year. 3. 56 discovered last year. 56 new comets discovered. All time 3,775. All on the Minor Planet Centre. These are primarily made by amateurs. These comets are named after amateurs. Amateur detection of near-Earth objects. I'm not going to read all of this out, but question, is it possible for an amateur astronomer to assist with detecting near-Earth asteroids or comets? If so, what would be the minimum telescopic aperture and type of photographic equipment required to conduct this kind of research? And the answer to that is that amateur astronomers can and do play an important part in detecting near-Earth objects. Today, more than 5% of all near-Earth objects are discovered by amateurs, and this proportion is on the increase due to the more increased sophistication of equipment that's available, if you've got the money to buy it. MinorPlanetCentre.net, based at Harvard University, is the organisation responsible for cataloguing and archiving all discoveries of small bodies. Why would amateur astronomers want to be bothering with this stuff, seeing these little, almost indiscernible dots in the sky? Well, how about getting a comet named after you? Wouldn't that be pretty cool? That's what they're after. They're after that sort of fame. They want a comet to be named after them. And Hale Bopp, discovered by Alan Hale and I forget the name of the Bopp, the first name of the Bopp guy. That was a typical example. That was named, and Hyakutake was another one that comes to mind. Comet Kohoutek. These are named after the people that discovered them. That goes into the history books. It's a good way to get into the astronomical history books, and quite fun if you can discover a new comet. So that's what drives these people. And you need what's called a CCD detector. It's a bit like what's in a digital camera. You know, these sensors that are now in digital cameras. Put them into a telescope and you can detect very faint objects, and you don't have to keep forking out to get your photographs developed. Because it used to be the case, of course, you'd photograph the sky, going back to when I got interested in astronomy in the 80s, when I started to get involved in the astronomy club. You'd have to get 1000 ASA film, stick it in an SLR camera with a 50mm lens, point it at the sky, attach it to your telescope, hope you caught something, go and develop the image, and see what was on it. And then if you were lucky, you'd get 2 pictures, you could put them on a blink comparator, and you might find a comet on there if you were lucky. Nowadays, you can have an automated computer program, scans the sky, takes a CCD image, saves it on your hard drive, takes another CCD image the next night, you compare that, you do a flash comparison on your screen, and you can see if anything in that star field has moved. And you can do probably a significant proportion of the sky every night if you've got the right software. That's what you can do now. That's why more of these objects are being discovered by amateurs. That's one of the reasons. So there you go. Amateurs play an important role in the discovery of comets. Right, but we haven't talked about what comets are. So we're going to talk about what comets are. Are they lumps of rock? Are they harbingers of doom? Everyone's seen the story about Comet Halley appearing in the Bayeux Tapestry from 1066, it being, an omen to King Harold, and so on. So what I've got here is a clip from the very nice electric comet video, which I've used a couple of clips from, and I'm going to play this to explain what comets are, or what you're told that they are, and I don't think that's always totally correct, as we're going to see.
It was only in the mid-20th century that a scientific consensus emerged on the nature of comets.